Dear student, welcome to the problem solving session part 2 on inverse Laplace transform. Just we recall the basic formulas which we used in the inverse Laplace transform in the previous sessions. In the part 1 video, we learned the basic ideas on inverse Laplace transforms and few problems we did. Just we have a quick recap. So this problem is direct problem. We apply inverse Laplace transform. Using the properties, we get the solution. Similarly, in this problem, we split the problem into two. A square plus 16 in the denominator, numerator s, and then L inverse of a square plus 16. In the numerator, we have 2, but we need 4. So what we did, we multiply and divide by 2. Then we can apply the formula. We get the answer. We get the answer sin 4t by 2 plus here cos 4t. Next problem, we use the first shifting theorem property. We take this s plus 2 outside, that is e power minus 2t, then L inverse of 1 by s square. So we write the answer e power minus 2t into t. And when we go for the fourth problem, we should be very careful. I cannot take this s plus 3 alone because I have s in the numerator also. So what we did, we add plus 3 and minus 3 because we have plus 3 in the denominator. S plus 3 whole square. Then simplifying this, we get the solution. Next, this problem, we took e power minus t outside by shifting property and we get 1 by s square plus 16. Here also to match the problem, I am multiplying and dividing by 4 and we'll get the solution. Whenever the problem is not in the proper format, we try to adjust this to the nearest whole square. So s square plus 2s plus 1, that is s plus 1 whole square plus 1. Then we proceed to solve the problem. And in the final problem, we have both numerator and denominator. So we should be little cautious. In this case, we took s plus 3 whole square, that is s square plus 6x plus 9 plus 1. And the denominator is done. Now we have to adjust the numerator also. I'm adjusting like s plus 3 plus 1. Then we can proceed with the properties to get the solution. Those who don't watch the video on part 1, go to the playlist, watch the video first and come back here. Now, in today's session, we are going to deal some problems. For example, 1 by s plus 2 into s plus 3. Here I cannot do anything. The problem is I cannot adjust my numerator or I cannot adjust my denominator. But all my formula, inverse formula, will work if you have L inverse of s plus a alone or L inverse of s minus a alone. But here we have s plus 2 into s plus 3. That is the problem. Now just we recap from our school days. Whenever there is two datas are there in the denominator, use partial fraction. Do you remember, students? Or how you simplify this? We take a by x plus a plus b by x plus b. Then our job is to find capital A and B. Next one, repeated factors. If the denominator has repeated factor, for example, denominator has x plus a, x plus b whole square. In this case, we write a by x plus a, b by x plus b, c by x plus b whole square. Suppose your problem has x plus b whole cube. In this case, we have to write d by x plus b whole cube. Hope you understand, students. Next, if the denominator has non-factorizable terms, for example, x plus a into x square plus b square. In this situation, what we do, we write a by x plus a plus denominator x square plus b square. For this, we write this as bx plus c. If the power is 2, we have to write bx plus c. If the power is 3, we have to write bx square plus cx plus d. And this is not the only way to express. I can express this as like first the non-factorizable term ax by b divided by x square plus b square. Then plus c by x plus a. Both are correct. Now we are going to see a very important content. When all this partial fraction will work. Suppose, for example, I am taking 1 by x plus 2, x plus 3. Partial fraction will work. X by x plus 2, x plus 3, then also it will work. Now suppose if I am taking numerator is x square, then I cannot use this rule. Or if my numerator is x cube, then I cannot use this rule. So what do you understand, students, from this? The highest power of the denominator should be greater than the highest power of the numerator. So the degree of the denominator is greater than p of x. P of x is some polynomial in the numerator. The degree of the denominator, degree means highest power. The highest power in the denominator should be always greater than the degree of p of x. So if you take 1 by x plus 2 into x plus 3, the degree of the denominator is x square, x into x square. But in the case of numerator, we have x power 0 because there is no x. So degree of the denominator is greater than degree of numerator. I can apply partial fraction. If you have x in the numerator, still the degree of denominator is x into x square. That is 2. Numerator degree is 1. I can apply. If I take the problem x square divided by x plus 2 into x plus 3, in this case, degree of denominator is 2. Degree of numerator is also 2. I cannot apply the partial fraction as it is. So we should be very cautious about this. This rule is applicable for all the three cases. Remember, degree of denominator should be greater than the degree of numerator. Okay, let us go into few problems. Find L inverse of 1 by s plus 2 into s plus 3. Always take this as capital F of s. Our aim is to find L inverse of capital F of s. Now check the denominator power, s into s square. The degree is 2. Numerator there is no s term, degree is 0. So I can apply partial fraction. Now we are going to write this as a by s plus 2 plus b by s plus 3. Now we have to take the LCM. Automatically the denominator will get cancelled. Don't be a school student writing all the denominator. So now a into s plus 3, b into s plus 2. I can write directly. So a into s plus 3 plus b into s plus 2. We have left hand side numerator 1. I am writing in the right hand side. Done. So now we have to find the constants a and b. To find the constant a and b, the easy way is take the number which makes the term 0. We have s plus 3. If I put minus 3, this term will become 0. I'll get b easily. If I put similarly minus 2, then I'll get a term. So always go to the expression and see what is the number I can put such that it makes some datas 0. So let me choose first minus 2. I'm going to put minus 2 in this expression. So minus 2 plus 3 into a plus b into minus 2 plus 2. This will become 0 is equal to 1. So we get a equal to 1 directly. Next we have to substitute s equal to minus 3. When you substitute s equal to minus 3, a term becomes 0. Then we get minus 3 plus 2 in b. Therefore, b equal to minus 1. So we found a equal to 1 and b equal to minus 1. This is done. Now we have to substitute here and then we have to apply L inverse on both sides to get the solution. While you write this constant a and b, write very legibly. Just write this part 1 by s plus 2, 1 by s plus 3. Substitute the values of a and b outside. For example, if a is 1 by 2, b is 2 by 3, write legibly like this 1 by 2 plus 2 by 3. Our case a is 1, so I don't want to write anything. B is minus 1 because it is helpful for you to apply L inverse easy way. Now applying L inverse on both sides, L inverse of 1 by s plus 2 is e power minus 2t. L inverse of 1 by s plus 3 is e power minus 3t. Therefore, my final answer is e power minus 2t minus e power minus 3t. Now, from the problem, what we understand, whenever L inverse of something is given, I can guess the answer immediately. My job is to find only the constant. You see, I have two terms. So I am going to get e power minus 2t, e power minus 3t. Plus, I want to find some constant a and some constant b. Hope you understand, students. So, in partial fraction, we have to find only the constants. Answer is immediately known by seeing the question. Next question, you see here, by seeing the question, I can write the answer immediately. 1 by s. We know L inverse of 1 by s is 1. Therefore, 1, s plus 1 is e power minus t, s plus 2 is e power minus 2t. So, I don't know the constant. Here I have to find a B and C. So my answer is ready. Only I have to find the constants. Let us find the constant happily, students. First write this as capital F of S. We have to find L inverse of capital F of S. Now see the denominator. The degree is 3 and numerator degree is 0. There is no S term. So I can apply partial fraction. So I express this as A by S, B by S plus 1, C by S plus 2. Now we have to take LCM. A into S plus 1 into S plus 2. Then B into S into S plus 2. Similarly, C into S plus 1 into S. All my denominator get cancelled. I have 1 in the numerator. Now my aim is to find the constant A, B and C. So what is the trick we are going to use? We have to take a number such that it makes some term 0. Here I have S plus 1. So I am going to take S equal to minus 1, which make this two terms 0. I will get B. Next I will take S equal to minus 2. Then it will make these terms get 0. I can find C from S equal to minus 2. And finally, if I put S equal to 0, then these two terms become 0. I can find A. So now we can easily find my A, B, C and we can proceed with the problem. So put S equal to 0. We get two terms cancelled. A into 1 into 2 is equal to 1. So A equal to 1 by 2. Done. Next. Put S equal to minus 1. These two terms get 0. B into minus 1 into minus 1 plus 2 is equal to 1. Therefore, minus 1 into 1 is equal to 1. B equal to minus 1. Next, substitute S equal to minus 2. Then these two terms will get 0. C into minus 2 plus 1 is equal to 1. So minus 2 plus 1 is minus 1. Minus into minus plus. We get 2C equal to 1. Finally, C equal to 1 by 2. Therefore, we found A equal to 1 by 2. B equal to minus 1. C equal to 1 by 2. Now, it's time to substitute in a very legible way. So 1 by 2 into 1 by S. B is minus 1. 1 by S plus 1. C is plus 1 by 2. We get 1 by 2 into 1 by S plus 2. Now apply inverse Laplace transform on both sides. We can get the answer easily. 1 by 2 L inverse of S is 1 minus L inverse of 1 by S plus 1 is e power minus t plus 1 by 2 e power minus 2t. Hope you understand, students.
Thanks for watching. Hope you found this video helpful. Subscribe to our channel and share it to your friends. See you in the next video. Bye bye.